Okay, welcome back. We have lesson 3.6 we're going to get ready to go through. It is comparing your ratios and rates. We've been working with ratios and rates for a couple of days now and how those relate to proportions. And now we want to look at how we can really utilize this unit rate concept to compare the rates to see best value, also to see, which one is the better deal when we're talking maybe you're buying something or you're comparing speeds, things of that nature. Okay, let's jump right in. So, ratio, rate, proportion, we've had those as vocabulary words in the past, but unit rate we've looked at before. But what we want to do is let's read it. It's a comparison of two quantities in which the denominator has a value of 1 unit. And there may be some times, to be honest, where your value of 1 unit may be on the top of the numerator, but the big thing is one of your quantities that you're comparing gets to the value of 1 unit, because then that tells you how much one thing costs, how much you're going in 1 hour, or how much you're producing in 1 minute. So that is what the idea is per unit, per that 1 unit. How much are you producing and how much, that kind of thing. So what's going on at that one is the crucial part. So let's jump right in. So Rob loves to snowboard in the winter. So he is looking at the cost of ski lift tickets for different mountains. You have Peak Point, which their cost is 5-day pack for $275.60. Then you have Green Mountain, and theirs is a 3-day pack for $174.75. Which mountain offers the better deal? We're looking for the cheapest price, right? Okay, so we're going to show our work of how we figure that out. You're essentially dividing when you do these types of problems, because to figure out, okay, I have for Peak Point, my ratio is $275.60, and it's for 5 days, right? We want to know the amount in 1 day. So you have to break up this. Instead of 5 days, we're going to split it. We're going to divide our big number here, 275.60, by 5, and that's going to tell you 1 day. The proportion for that also, if you were to set it up equal, we want to know 1 day instead of 5 days, right? And our unknown or our variable is here. So you essentially would divide by 5 to get to that 1 day, but we got to do the same thing over here to get to that unknown variable. So that is the reason we're going to just divide by 5, and it will work the same for our other one. So let's do it. 275.60 divided by 5. So let's work that out. Our 275, we can't do anything with the 2. We can't make a group of 5 with 2. Here we go. We can make this group though. 25, 2, bring your 5 down. Oh, we can make another group of 5. That'll give us 25. Subtraction, that's 0. Bring your 6 down. I can make, oh yeah, put my decimal so I don't forget that. With 6, I can make one group. That's 5. Do your subtraction. Bring your 0 down. Oh, and then we can make 2 groups with that. So at Peak Point, 1 day cost $55.12. Okay. So now looking at Grand Mountain. Grand Mountain is going to cost us $174.75 for 3 days. Again, essentially, we're just dividing our 174.75 divided by 3, but I'll set up the proportion so you understand why we're doing that. Because again, we want 1 day. So here to here would be divided by 3 to get to that 1 day, right? So you got to do that also on the top. That's how you get that divided by 3. It's important that you get that down because I won't set up the proportion for some of these other ones. I'm going to straight divide. So let's do our division. 174.75. And we're going to divide it by 3. Can't make any groups of 3 from 1, but I can with 17. That's going to be 5 groups. It gives me 15. Do my subtraction, get 2, bring my 4 down. Up, now I can do 8 groups. That will give me 24. 8 groups of 3 is 24. Subtraction, bring my 7 down. Don't forget to add your decimal. Go straight up. I can make 2 groups. 6, 1, bring this down, that's 5. And now I'm back to 5 groups. It's 5 groups of 3 is 15. 0. So here, 1 day cost 500. Oh, not 500, $58.25. So it may appear because the 174 is a cheaper price, but when you talk about best value, the amount you're paying per day, look, our peak point is less per day. It's $55.12, where this guy over here is $58.25. So that's how you find the best value when you're working with some of these problems. You can use the unit rate to compare the best value. So this is a review key point. The unit rate is a comparison of 2 quantities in which one of your units is 1, is what we're doing. So there's several ways you can calculate it. We did the division, but we also, because it says here, you can do your division, divide, or simplify the rate, or you can set up the proportion like I just did. You're going to get the same the same answer from the process. It just looks a little different. Whichever one makes more sense to you. Unit rates can be scaled up or down to find equivalent rates. They are essentially helpful when given unfriendly values. So they're really good when you want to fill in those tables. If you find the unit rate, it's really easy to multiply that 1 times whatever number you're looking for. So if I find out the cost of 1 day, it's really easy for me to find out the cost of 5 days because I just multiply by 5, right? Or if it's 10 or 15 or whatever. But I know that unit rate, so it's easy for me to find that next number. Let's keep moving. So this is just an overview of each strategy. This one here, Tillman travels 100 meters every 20 seconds on his bike. How far did Tillman travel per second? So again, they just did the division here, right? 100 divided by 20, 100 divided by 20 equals 5. So 5 meters per second, okay? And then they wrote it a couple ways here, okay? You can set up as a proportion, kind of how I did it there. So you could see that, okay, look, I'm going from here to here. That's divided by 8. From here to here would be divided by 8, all right? And 132 divided by 8 would give you your 1650. So it's 1650 per pizza. So again, you're trying to find that per hour, per pizza, situation. And you can create the table like we've done in the past. It's a ratio rate table. So essentially, here's our unit rate, all right? So if they gave us 3 boxes in 1/2 hour. So that's what they gave you here. But we knew we wanted to go to 1, which is pretty much double. So you had to times 2. And that gave you 1 for my top rate. And you had to do times 2 on the bottom. So 6 for my bottom. Okay, so we had to scale up to go to 1 because this number here was less than 1. Okay. But now that we have the unit rate, it would be real easy for us to find. So what about, if we were doing 3 hours, it would be real easy to go from 1 to 3. We're multiplying by 3 now. So that would be 18 boxes, right? Cool. Let's move. This is asking you, and we'll have this discussion in class, and you can have it with yourself. Which one do you like better? Do you like to divide? Do you like to set up the proportion? Do you like to look at the table? Whichever one works for you, you will get the same answer. I personally set up the proportion and just straight divide. Those are the two I do. I typically don't do a table unless I'm going to probably make a graph, which, it's useful to have a table with the points. Or if they gave me a table and I have to fill it in, that's another time I use the tables. So we've already talked about how unit rates are helpful when making comparisons. You can see the per day, the per rate type of thing, so that you can know who's the better deal or who's doing this thing faster, the different types of situation here. So in order for you to be successful, you're going to write each rate as a fraction first, calculate the unit rate, and then you're going to compare those rates. So, example. A principal is going to buy some lanyards, like at Yes, all we have those blue lanyards there. So he's going to buy lanyards. Company A charges $1,200 for 300 lanyards, and Company B charges $1,401 for 467 lanyards. They want to know how much does it cost for one lanyard at each company. Okay. So again, Company A, here's our ratio rate for 300, and then Company B, here's our ratio rate. Okay. All right. So let's go ahead and work out Company A first. So we'll say Company A here. You write it as a fraction first. That was our CFS. 1401, 467. Okay, remember that. Then it says calculate the unit rate for each situation. So you can do the proportion. I'm just going to straight divide. I told you I was going to start doing that. So now we have 1401 divided by, whoops, we're not going to have enough space. Let's do this. I'll write the divisor first. Man, I'm messing up, guys. Bear with me. 1401. So just looking at, that's actually Company B, guys. I'm just messing up all kinds of ways tonight. But it's fine. We'll work it backwards. B, this is almost 450. So if I estimate that in my head, 450 plus 450 is only 900. So that's not quite 14. So I'm going to come over here and do 467 times 3 and see what I get. 21, 18, 19, 20, 12, 13, 14. 1401 perfectly. So this, I can make 3 groups, 1401. So essentially $3 per lanyard. Okay. Now we'll do Company A over here. Write it as a fraction. $1,200, 300 lanyards. So here we go. Let's divide it out. 1,200 divided by 300. I know that is 4, because 4 times 3 is 12, and then add the 2 zeros will give me 4 times 3 is 12, add the 2 zeros, that's 1,200. So this one is $4 per lanyard. Okay, so Company B is cheaper. And that's because when we found that unit rate, we found one is $3 per lanyard. This one here, this one is $4 per lanyard. So which one would you want to pay? $3 or $4? $3 is a cheaper buy, right? So that's our explanation. Let's keep it moving. Example 2. So Taylor and I think it's Romney each earn an hourly wage. Taylor earns $308 for working 14 hours. Romney earns $288 for working 12 hours. Which statement is true? All right, so let's take a look at it. What you could do here, again, is find the unit rate, and you would be able to know. Because we don't know who earns more, Taylor or Romney. That's what F and G are saying, which one earns more. And then these give us exactly unit rates. Either way, we need to calculate them. So for 14 hours here, and 288 for 12 hours. Notice I'm circling the important information. So now let's go ahead and work this out. So 288 for 12. So what we're gonna do is we're gonna divide that guy out. And remember, this is Romney. So 288 divided by 12. I can't do anything with the 2, but 28, I can make 2 groups. And give me 24. 4, bring 8 down. Now I can make 4 groups. So Romney is 24 per hour. Now let's see about Taylor. Taylor is 308 and for 14 hours. And now we do our division. I can't do anything with 3, but I can make 2 groups here, which 28. This is 2 left over. 8. Another 2 groups is 28. So 22 per hour. $22. And Romney is dollars as well. Don't forget her units. So once we're looking at this, we can now go down the list. We know how much they both make per hour. We know these are both wrong. You can get rid of these because neither one of them, they don't make $26.80 or $21.34. We know their rates. They're right here. But we can look at these. Taylor earns more per hour than Romney. Taylor is 22. Romney is 24. So that's wrong. And Romney earns more than Taylor. So here's your answer, G. All right. I encourage you to stop here and try to work this one out yourself. Then unpause and see if you got it right. The 6th grade wants to buy t-shirts for an entire grade level. They found 2 different deals. Deal A offers $352 for 44 shirts, and Deal B offers 72 shirts for $504. How much does it cost per t-shirt each deal? So we're doing the same thing here, guys. I say the same thing. So A is $352, 44 shirts. B, here's our ratio here. All right, so let's work out A. So A is here. It is 352, 44 shirts. And we do our math. 352, 44 shirts. And you may not know your division all the way here, but if you want, you can do that other method. I forgot what the exact name of it is, but where you make your groups. For example, here we could say what? We can do times 2. We can keep doing 2 for a while and see what we get. 2 would be 88. We do our subtraction, 4, 1. This is the other division method. If you are comfortable with the traditional algorithm, go ahead and do that. 8, 14 would be 6, and 2. You can do another group of 2. Keep doing that. See what we have here. 5, 1, this would be 6. 1, that'll be 7. You can do another group of 2. 16, that'll be 8. That'll be 8. Oh, look. And then we got 2 more. That'll be 88. And that, now we're to 0. So now we can count these up. 2, 4, 6, 8. So our 8. So this is $8 per shirt. Okay. Deal B. Let's check it out. So B, we write our deal out, is $504, 72 shirts. So again, do our division. 504. When you get these larger numbers, you can do this other method where you're just figuring out, okay, you don't have to sit here and try to multiply it. You can try to kind of guesstimate it. We can say this is 70. How can we get 70 close to 50? I know 7 times 6 is 42. 7 times 7 is 49. Let's try 7. See what happens. 7 times 2 is 14, right? 49, 50. Look at there. So 7 will give us 504. All right, so that means that this is $7 per shirt. So there you go. It says which deal is the best. We're talking cheaper per unit. For this one, B is cheaper. $7 versus $8. Okay, let's move on. All right, CFU 2. Megan and Desmond each added the same amount of water to their aquariums. Megan mixed 5 milliliters of chemical solution with every gallon of water for her aquarium. Desmond mixed 8 milliliters of chemical solution for every 2 gallons of water for his aquarium. Which statement is true? Megan used more solution per gallon of water than Desmond because 5 to 1 is greater than 8 to 2. Okay. Megan used more solution per gallon than water than Desmond because 5 milliliters is greater than 2 milliliters. And then we have some more because 8 milliliters is greater than 5 milliliters. And then you have because 8.2 is greater than. So for this one, your real important thing is to look at the ratios. You don't just look at 5 milliliters and 8 milliliters. Write out your ratios. So this one is, so Megan, she mixed 5 milliliters for every 1 gallon, right? Desmond, on the other hand, he mixed 8 milliliters for every 2 gallons, right? So we need to see whose unit rate is greater, okay? So for this one, for Megan, this is already her unit rate. But Desmond, we got to get him to a unit rate. If we want this to be a unit rate, we need to be 1 down here, right? 1 gallon. To get from here to here, you divide by 2. From here to here, we're going to divide by 2. 8 divided by 2 is 4. So Desmond is using 4 milliliters for 1 gallon. So he's using less solution. So Megan is using more solution because 5 milliliters. No, it's not because of the milliliters, though. We don't want these two because they're talking milliliters. Megan, you did use more solution. It's because her 5 to 1 is greater than his 8 to 2. That is the correct answer. So although B says use more solution, that's true, but their reason is not true because the 5 milliliters is greater than the 2. That's not the reason that we're looking at this. All right. So you can practice this with a partner. If you're at home, you can practice this with your parent. Caroline is getting a new car for her 16th birthday. Her parents made her compare the gas mileage of 3 different cars before they helped her buy a car. She found the results below in the advertisement. So you got 3 different cars and 3 different gas mileages. So our first question A, it says, how far can each car travel on 1 gallon of gas? We're trying to find the unit rate, right? So let's do the Avalar first. So Avalar, we'll call it A. This one is 480 miles to 10 gallons. So for 1 gallon, if we divide them, it's going to be 48. Because 480 divided by 10, because we would divide this by 10 to get there. That would be 48 miles in 1 gallon. All right. So now the S, or the Centaur, is 400 miles, 8 gallons. So to get that to 1, it's literally 40 divided by 8, which would give us 50. Because 8 times 50 is 40. 400, I'm saying. 400. Sorry. So miles, gallon. And then let's do our C, which is 360 miles on 9 gallons, which this one here would be 360 divided by 9. So for 1 gallon, we would have 40. Okay. So what this tells you is our first car, on 1 gallon, it can go 48 miles. Second car can go 50 miles. Third car can go 40 miles. So it already tells us who can go the farthest is Centaur. They can go the farthest, right? Which car gets the best gas mileage or travels the most per 1 mile? Explain your answer. We just saw it. Centaur. Centaur travels the most per mile because the unit rate is 50 miles to 1 gallon. And that's more than the others. What is the difference in miles per gallon a car can travel between an Avalar and a Comstar? So Avalar was 48 and Comstar was 40. So 48 minus 40 is 8. 8 is the difference. So let's use the correct units when we're talking. Sorry about that. 8 miles is the difference. You could also say Avalar can travel 8 more miles per gallon. There you go. Let's keep it moving. So now we got some evaluate questions to knock out. At Arcade Palace, a child can buy 16 video game tokens for $4. At Alibaba's, a child can buy 10 tokens for $2. Which statement is true? So they're going to ask who's cheaper, who's more expensive. So let's go ahead and find our unit rate. So 16 for $4 and 10 for $2. So let's set it up. Arcade Place is 16 for $4. So for $1, we would get 4, because 16 divided by 4 is 4. All right. And then Alibaba, whoops, I did that in blue. Alibaba is 10 tokens for $2. So for 1 token, it's going to cost, for $1, we get 5 tokens, I should say. And over here, $1, we get 4 tokens. So Alibaba, you get more tokens. So games at Arcade Place probably take longer to play. They don't have anything to do what we're talking about. Tokens are relatively cheaper at Alibaba's place than at Arcade's place. That's kind of true, because we can get more tokens for $1 at Ollie's than we can. Tokens are relatively cheaper at Arcade Place. Well, they're not cheaper at all, because you only get 4. And then tokens at Arcade Place and Alibaba cost the same. That's also not true. So G is our answer. Andre made 135 working 9 hours, making the same amount each hour. Chastity made $102 working 6 hours, making the same amount each hour. Which statement is true? So again, you got to find your unit rate so you know who's making more money here. Andre, 35, and Chastity, 102 for 6. So real quick, we can set that up. Andre is 135 for 9 hours. So we figure out how much he's making in 1 hour. So we're dividing by 9. 135 divided by 9. If we don't know it, we can do it out real quick. 13, that's 4, 5 from here. So he's making $15 in 1 hour. Now Chastity, on the other hand, let's see. She's 102 in 6 hours. So again, we're dividing by 6 to get our 1 hour, right? So 102 divided by 6. She is making $17 an hour. So Chastity's making 17, Andre's making 15. So look, I can already see C. That's true. Andre earns $2 more. Nope, he's actually 2 less. Andre earns more. Nope, he's actually 2 less. So it looks like it's going to be C. I'm not sure if there's, let's see if there's another answer choice. Yep, Chastity earns 32 less. Nope, that's wrong. We found our answer. All right, so before you go to iExcel and work on this code, we are going to work on this today. But before you do that, I want you to finish our elaborate questions, okay? 3 teachers, Mr. Roberts, Miss Hawkins, should have been 2 teachers, each took a road trip over the summer. Below is the table that shows the amount of time they drove and how far each of them traveled, okay? So they want you to determine what's true from that, okay? So again, you got to set up your unit rates. 315, 5 hours. We need to figure out how much in 1 hour. Do your division. 315 divided by 5, 6, 30, 1 left over. Drop your 5, 3. So 63 in 1 hour. So over here, we got 243, 3. Let's do our division. 243, 3. This is 8, 24. Drop your 3, 1. So this in 1 hour, we're doing 81 miles. Okay. So Miss Hawkins drives at a faster rate than Mr. Roberts. So Miss Hawkins is driving 81 miles in an hour, and he's driving 63 miles in an hour. So Miss Hawkins is driving faster. So for this one, Miss Hawkins does drive faster. That's true. Mr. Roberts drives at a faster rate. That's false. Mr. Roberts drives at a rate of 63 miles per hour. Also true. We found that. It's right here. All right, let's keep it moving. Sarah needs to buy 15 pizzas, so she compares the cost of different pizza stores below. Which pizza place is the best deal? So she's buying 15, remember? But that might not be important because we just want to know who's cheaper per pizza. Let's see. Pizza Hut or Little Carter's Pizza? Those don't sound like anything, do they? So again, let's go. Pizza Hut is $174 for 29 pizzas. We do our division. 29 pizzas. Remember, if you don't, I kind of do guess and check based on my knowledge of estimating. This 29 is almost 30, and we need to get 30 to almost 170. I know 30 times 5 is 150. 30 times 6 is 180. Let's try that. 29 times 6. 9 times 6 is 54. 12 plus 5 is 17. There you go. So it's 6. Okay. So this would be $6 for one pizza. So now Little Carter's is $56 for 8 pizzas. And I think we can do that one kind of mental math. 56 divided by 8 is 7, right? So this one is $7 per pizza. Okay. So rate as a fraction. Oh, I didn't even write it. I can put them in here though. No, 174 over 29. And this is 56 over 8. And then the unit rate per pizza here is $6 per pizza. And this one is $7 per pizza. Gotcha. So, and then I would go with Pizza Hut because they're cheaper, right? Miss Johnson adds 2 cubes of sugar to her 6-ounce cup of tea. Mrs. Hong adds 3 cubes of sugar to her 9-ounce cup of tea. Which statement is true? Again, unit rates, set them up. 2 cubes, 6 ounces. 3 cubes, 9 ounces. So sometimes you don't have colors during the test, so you can do different markings. So we're going to put underlines for those so we know they go together, and circles for these because we know they go together. So 6 ounces, 2 cubes. So for 1 cube would be for 3 ounces, right? So if we do the opposite way, 6 ounces, so now we have 9 ounces, and 3 cubes. So 1 cube here is for every, 3 ounces. So they have the same kind of unit rate. They're, for every 3 ounces of tea, they're both putting 1 cube. Okay. Miss Johnson's cup of tea is sweeter. No, I don't think so. Miss Hong's cup of tea is sweeter. Nope, I don't think so. The cup of tea is equally sweet. Yep. Neither cup of tea is sweet. That's not true. They got sugar. There you go. All right, number 4, look at the table of cost for different size bottles of salad dressing. Okay. Which size is the best buy? So we can work these out real quick. So a couple of ways that we can do this. Again, we're trying to get our ounces to see how much per ounce for this. So if we write this out, 12 for 120, right? We can see how much is in 1 ounce. Okay, we're trying to see how much is in 1 ounce. This is 12 ounces. We're trying to see how much is in 1 ounce. Okay, so really we're dividing by 12 to get here. So this is a little tricky, but this will be really 120 divided by 12, and that's going to tell you how much per ounce. And it's actually nice because if you put the decimal on the inside, you don't have to do all that moving the decimals, right? So 0 here, bring up your decimal, then 1 because it's 12. Bring this down, 0. So this one is 10 cents per ounce. All right, so let's do the same here. I'm not going to keep setting up the proportions. Y'all see what I did here to do that. So but what we're doing is the same thing. I'll change the color for you though. 16. We're dividing up our price to see how much per ounce. 0, 1. 119, 1. So it's 11 cents. You could keep going, but I don't think we have to here because you're looking like we're thinking money here. So this is 10 cents, that's 11 cents. Of course, you got 1 left over, and you could keep going until you terminate the decimal, but I think we're 2 decimal places will let us compare here real quick. So 28 to 70. This is 0. We still can't even do this. That's also 0. So now, let's see, 28 times like 9. Let's see what that is. 72, 18 plus 17, 18, 19, 20, 21, 22, 23, 24, 25. So it's about 9. This is about 9 cents. Okay, of course you have some more. You can keep going, but look, you don't need to. We got 9 cents, 10 cents, 11 cents. Let's do this last one. 30 and $3. All right. So 30, that'd be 0, 1 here, 30, 0, that's also 1 here. So you got 2 10 cents, a 9 cents, and an 8 cents. So which one is the best buy? The 9 cents right here is our best buy because it's the cheapest. So the 28-ounce bottle. So when you're dealing with money, all you need is those 2 decimal places because you're looking for how much it's a cost. All right, I think these are our last 2 problems. It says the table shows the number of red, blue, and white ribbons won by 4 girls during last year's gymnastics season. Which girl has the largest ratio of red ribbons to total ribbons? So largest ratio of red ribbons to total ribbons. Okay. So Ann, I'm going to work them right underneath. So Ann's is red ribbons. And her total, let's add them up. 8 plus 2 is 10, then 14. Okay. To figure out our unit rate, send this to 1. This would be 7, right? Because you're dividing those. Just to go from 2 to 1, it'd be divided by 2. We divided this one by 2. That's how you got that. Let's keep working. Our red ribbons is 5. Total is 10, 15. All right. So for 1 ribbon, this would be divided by 5, 3. Red ribbons is 4. A little different color. 4, 2, 10, 14. Right? So now, to do it, to get this to 1, divided by 4. You can't really divide that by 4. But, let's see. 14 divided by 4, it's going to be a decimal. So 3, 12, 2, you can bring that down, So it will be 3.5. Okay, 3.5. And then last but not least, we got chin. We got 6 red, and 1519. Right? So to get this one to 1, you'd have to divide by 6. 19 divided by 6. 3. This is 18. 1, circle. Adding a decimal and a 0. Still 1, 3.1-ish. Alright, this would be 3.1 and some change, but we're looking for the largest ratio. So our largest ratio here, I would say, is 1 to 7. So for every... it's kind of tricky, because essentially it would be technically Karen. Our largest ratio is 1 to 3. And the reason being is for every 1 red ribbon, she has 3 total ribbons. So if we look at all of these fractions and see which fraction is bigger, our 1/3 is bigger than all of our others. It's a little confusing, okay? Because if we were to divide out 1/7, that would be a smaller ratio, okay? And I'm gonna check on that one to make sure that I'm correct, but that's how I would read that. Would be, that's the larger ratio. It's a tricky worded question. I don't really like the way it's worded, but we'll keep moving for the sake of time, because it could either be conceived as Karen or possibly Ann, depending on how, I don't know, they're asking it. But I say Karen. Which is the better buy? Cheapest cost per pound. 6 apples for 90, 4 for 56. Okay, this is just one of those ones you have to work out the unit rate for it. So again, we have to do them out. So 90 cents divided by 6. See which one is the better deal. 1.30. So this one is 15 cents. A is. Now B, 56. 4, 1, 1.16. That one's 14 cents, so that one's cheaper so far. 9. 0, 1, 9, 5, 4. That's 6. So that one's 16 cents. That one's more. And then we got 10. That's why it's really important for you to be comfortable with division. This is something you'll have to do on these tests. All right, and this will be about 15 cents. So clearly you don't even have to keep going. Of course, this would technically be 5, and we could go here, and yeah, but this one is the cheapest one, 15 cents. So that is our B. So this one here is our cheapest. I know that was a lot of work, a lot of division, but I'm glad you stuck it out. Hopefully you got those right, and if not, you saw, what you could have done differently. All right. Think that's it. Yep, that's it. See y'all later. Peace.